Not on the last method, that is third method in the Mohr circle. So whenever the stress is acting in two mutually perpendicular direction and shear stress with shear stress. So this we have solved in analytical method. So stress in x-axis, that is sigma 1 is given 65, sigma 2 is in y direction 35, and shear is 25 Newton per mm square. Okay, I think finished with taken the problem. So we'll start with this. This is a given problem. So the stress in x-axis is a major stress. Major stress is sigma 1. Major stress is sigma 1. Major stress is sigma 1. That is 65. So this will solve the problem. 65 Newton per mm square. Then stress in y-axis is the minor stress. This is 35. That is sigma 2, 35 Newton per mm square. Then we have a shear stress. Shear stress, that is tau. Shear stress is 25 Newton per mm square. Then oblique plane, the plane is inclined, Mn. So we named it as Mn. An oblique plane is inclined at an angle of 45 degrees with respect to the vertical. So if it is 45, so it is vertical, so directly it is theta. Theta is 45 degrees. Horizontal inclined ಆಗಿದ್ರೆ it should have been 90 minus theta. Okay. So these are the given data. We need to solve it by Mohr circle method. So the steps to solve it by Mohr circle method. First, take a reference point. First, take a reference point. This is all by graphical method. You need to have a compass and instrument, basic instruments to draw it. So take any reference point on your page. Okay. So before going to that, you take some suitable scale first. Take some scale. So as you can write a 10 Newton per equal to 1 centimeter. So since it is 335, 25, so if we can take it as 10 Newton per mm square is equal to 1 centimeter or any suitable scale to draw it on a sheet. Okay. So first I have taken any reference point on the page and name it as point A. So draw the horizontal line. So take a reference point, draw the reference line next. With the scale, what you have taken, sigma 1. So it is 65. As per my scale, it should be 6.5 centimeter in your scale. So and measure and mark it on the reference line and name that point. And name that point as B. So this A to B is sigma 1. So what I have taken is, first I have taken the reference, take a reference point with a scale, with a suitable scale, what you have taken. Okay. Next, take sigma 2 for the scale. So it is 35 to 3.5 centimeter on a same horizontal. So measure sigma 2. So this is sigma 2, name it as point C. Sigma 2, a major and a minor stress we have taken. Major and minor stress both. Okay. Next, after getting the two of these stresses on the reference line, next drop a vertical from end point, from both the end points. So that is from point B and point C. Drop a vertical from point B. At point B, you drop a vertical downwards. That is perpendicular. Draw the perpendicular from point B downwards. And at point A, drop a vertical upwards. Okay. So this is a vertical what we have drawn. Next, after dropping the perpendicular or drawing the perpendicular downwards at point B and above the line at point C, there is one more data. You have taken this, and there is shear stress. For a shear stress with suitable scale, cut the arc for the vertical what we have drawn. For the vertical what we have drawn. For my scale, 0.5 centimeter, it is 25. Measure 2.5 and cut the arc. For both the verticals what we have drawn. Next, with the end points what we have drawn. So at the end point, connect both the end points. Connect these two end points. So this measures what? This is tau. The height is tau at both the ends. It is tau. So you can name the points. You can name the points as G, F, and also this measures. Okay. So now Use the center with this as center. Subscribe a circle. Subscribe a circle. You can name this point as O. Subscribe a circle with OF or OG as radius. With OF or OG as radius, draw the circle. Okay. With OF or OG as radius, draw the circle. Next step. Okay. Next. So next, I have taken this tau data also. Next, the remaining data is theta. Theta. Next, with OF as reference, with OF as reference, with OF as reference, draw two theta line. Draw two theta line. That is 2 theta is 90 degrees, right? So take your protractor here, measure 90 degree with OF as reference, right? So measure 90 degree and extend that line till the circumference of the circle, till the circumference of the circle. So this is angle is 2 theta. So measure 2 theta with OF as reference and extend that line to meet the circumference of the circle and name that point as ED, name that point as ED, right? From the point E, next, last step, that is, from the point E, drop a vertical, to meet the reference horizontal line. This is 90 degree. Can name that point as D. Name that point as D. Okay. The line AD, if you measure length AD will get you the normal stress. So that is you measure its length into the suitable scale what you have taken. So if it measure AD, if you measure AD will get you the A to D will get you the normal stress. Okay. And if you measure E to D, E to D will give you the tangential stress. E to D is tangential stress. So that is same length into scale. What length ED measures? Next, if you connect the line E to A, E to A will get you the resultant stress. A to E or E to A. A to E will get you the resultant stress. Okay. The normal stress and tangential stress on the oblique plane. So you want to do it to the scale, you measure ED. ED is the tangential stress. A to D will get you the normal stress. So if you want resultant stress, A to E will get you the resultant stress. And if you can measure this inclination, it gives you the resultant stress inclination with the normal stress. So this finishes The module 2, we want to measure the angle of inclination resultant stress. This inclination will get you 5. That you need to do it. You need to do it and you need to write the answer, how much it is. I don't know. Okay, you want to do it to the scale and measure and write the values, how much it measures.